This is section 5.6, net change. In this video, we're going to go through number 11 in your book, and this is an example where it's asking us to find both the displacement and the distance traveled of some function on some interval. Alright, before we go through this problem though, let's first talk about displacement versus distance traveled, because I think this is a concept a lot of students struggle with. So displacement is just the difference between your ending and your starting position, whereas distance traveled is the actual magnitude, the actual value of the total distance that you went. So, for example, let's say that I'm starting on the first floor of Sid Rich, then I walk all the way up to my 4th floor classroom. I walk up a gajillion flights of stairs, and then I walk back down to the first floor. My displacement in this case is going to be 0 because my ending position, the first floor, and my starting position, the first floor, is the same. So my displacement is 0. But if you were to actually walk up and down those gajillion flights of stairs, you know that you actually traveled some distance. You feel it. So the distance traveled is some number. So if I were to have my position function, I could just plug in my values that I'm interested in, whatever time I'm interested in, and solve for my distance traveled. But what I'm given in this problem is a velocity function. So I'm going to go ahead and draw out what this function looks like. It looks kind of something like this. And remember, the relationship between velocity and position is the integral. The integral of velocity gives you the position function. In other words, the area underneath this velocity curve gives you position. All right, and that's what we're going to use in order to solve this problem. But remember, we still need to worry about displacement versus distance traveled. Displacement is just the total area or the total position added together, whatever that is. But the distance traveled, we want this magnitude plus the magnitude of this negative area. In other words, we want to make this negative area positive so that these values won't cancel and we'll get an actual value of what our distance traveled is. Because right now, if we were to take this positive area plus this negative area, we would just get 0 because our displacement is 0. That's what displacement gives us. But our distance traveled, we want to take this positive area and this negative area and add the magnitudes together so that we get an actual number of what our distance is. Okay, so let's apply this to this problem and hopefully it'll make more sense. So we're going to start with our displacement because that's the easier one. Our displacement we just find by taking the integral of this function on whatever interval they're interested in. Do the same thing we've been doing all chapter. So you go from 0.5 to 2 of our function, and I'm actually not going to solve this out because we're going to do it again in the next step. But if you were to solve all this out, you get the displacement of this function from 0.5 to 2 is equal to 0. Okay, but when we solve for total distance traveled, we'll need to add a couple more steps into it. So remember, we said that total distance traveled, we want this positive area plus the magnitude of this negative area. Well, how do we know where the negative area is? We need to figure out wherever this function crosses the x-axis. In other words, we're going to take this function and set it equal to 0 and split up our integral so that it's this area plus the magnitude of this area. Alright, so taking my function, setting it equal to 0, and solving for t, I get that t squared is equal to 1. And so taking the square root of both sides, t is equal to both positive and negative 1. But since t is a unit of time, negative 1 doesn't count, so I just get that t is equal to 1. And that's this value right here. That's where the function changes from positive area to negative area. So I'm going to split up my interval at t equals 1. So now it becomes from 0.5 to 1 of my function plus the integral from 1 to 2 of my function. All right, but remember, I want the magnitude of both of these areas. So what I'm going to do is just take the absolute value of both of these integrals and add the magnitudes together. And I think this is where a lot of mistakes come in because there's a lot of integrals going on and you're plugging in a bunch of different numbers. So I find it's easiest to take it one integral at a time. So starting with this first integral here, we take the integral of the function, add 1 to the exponent, multiply by the reciprocal, we get negative t to the minus 1 minus t from 0.5 to 1. Plugging in our top number, 1 to the negative first just gives us minus 1 again, minus, when we plug in 1/2, this becomes negative 2 minus 1 over 2. And distributing this negative, we get minus 2 over here, plus 2 plus 1/2. Negative 2 plus 2 gives us 0, and we're left with just the absolute value. Remember, we still have all these absolute values over this entire thing. Absolute value of 1/2. And we're going to add that to whatever we get when we do the same thing over here. So doing the same thing on this side, take the integral again, and we get negative t to the minus 1 minus t from 1 to 2 on this side. Plugging in our top number, we get minus 1/2 minus 2 minus negative 1 minus 1. And doing the same thing, we get minus 1 minus 2. Negative 1 minus 1 gives us negative 2. But minus a negative 2 becomes plus 2. And so this becomes negative 1/2. But remember, we still have these absolute value signs around it. So now I'm going to move up here so I have more room. Now I have the absolute value of 1/2 plus the absolute value of negative 1/2. So this just becomes 1/2 plus positive 1/2, which equals 1. And this is my total distance traveled. Okay, so there were a whole lot of steps in this problem, but brief recap. For displacement, you just find the integral over this time interval, just like we've been doing the entire chapter. Nothing new with that one. But for our total distance traveled, we want the total magnitude. So we want to take this negative area, make it positive. The way we do that is we see wherever the function equals 0, and we split up the integral based off that number. And then we take each integral, find the absolute value of it, so that we get the magnitude of the total area, and we just add it together to get total distance traveled. All right, there's a lot of steps to this one, but once you do one problem, you know how to do all of them. So hopefully this was helpful. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in, but all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.